What I'm going to try to explain to you is a problem-solving technique called dimensional analysis. And it's used often in chemistry as a way of solving problems which you might not normally know how to solve. The problem I'm going to illustrate dimensional analysis with is a metric conversion. And I'm using a metric conversion because at least the units of the metric system might be somewhat familiar to you. So remember, this is the process that you're trying to understand. The problem I'm giving you is a conversion of 450 centimeters to some number of nanometers. Now, the first step in dimensional analysis is to form or to figure out what are called equalities. And an equality is the relationship that you're going to use in the metric system to figure out how to solve this problem. The book we have has a table, and the table I'm going to give you will have the common metric units that you need to know how to convert in and out of. These are the ones we'll be using in chemistry. The first one, K, stands for a kilo, and a kilo in the metric system is equal to 1,000 base units. Written in scientific notation, that's 10 to the third. Now, what a base unit is whether you're talking meters or seconds or liters or grams, it's whatever the base that you're working with. So it can be meters, it can be liters, whatever. Okay. The other commonly used equality is going to be a deci. A deci is equal to 0.1 of a base unit, or 10 to the negative first. You're going to use centas. They're equal to 0.01 or 10 to the negative second base units. You're going to use milli, 0.001 base units, 10 to the negative third. You're going to use, once in a while, a micro. That's written as a mu, it's called. It's 10 to the negative sixth, very small base units. And then nano. There's a unit in the text that we're going to be using nanos often. And it's equal to 10 to the minus ninth base units. So now I have the table from which I'm going to figure out these equalities. I look up at my problem and I see that I'm talking centimeters. So I go over here, and where's cena? Cena is right here. Okay? So I am going to use this equality. And I'm going to write it in the base units that I need. I need the fact that for every 1 centimeter, there's going to be 0.01 meters. So that's what I mean by the base unit. Okay. Now I'm also looking up there and I see nanometers. Well, nanometers are down here, so this is the other equality that I got to use. And it states that for every 1 nanometer, there's going to be 10 to the minus ninth meters. Now, after I've figured out my equalities, I do something called conversion factors. So the second step is the conversion factor. Now, as you get better at doing dimensional analysis and problem solving, you're not going to have to go through all these steps. You're going to do them in your head, and it's really easy. It's really simplifies these problems. So what a conversion factor is nothing more than a ratio of an equality. So I'm going to write these equalities in the form of a ratio. And there's always 2 ratios for every equality. So for the first equality, 1 centimeter equaling 0.01 meter, I'm going to get 2 possible conversion factors. There's always going to be 2. Okay, the first one would place 1 centimeter on the top, 0.01 meter on the bottom, and the other one just reverses it. 0.01 meter on the top and 1 centimeter on the bottom. Do the same for the nanometer equality. It's going to look like this. Okay, you get 2 of them. And again, once you figure out how to do this, you're not going to have to write all this out for every problem that you do. 1 nanometer on top, okay? And then the fact that for every 1 nanometer, there's 10 to the minus 9th meters. That goes on the bottom. Reverse it, 10 to the minus 9th meter on top, 1 nanometer on the bottom. Okay, now, third step, oops, I wanted that in red. Oops, I didn't want to erase that. Let's go back. Kick that was 10. Okay. Third step is I am going to solve this problem, and I am going to solve it not by thinking about the math. I'm not going to be thinking, do I have to divide 450 by 100? Do I have to multiply it by 0.01? Do I have to multiply it by 10 to the minus 9th? I am going to focus entirely on the units. In science, every number we use always has a unit attached to it. Dimensional analysis is a way of solving scientific problems using that fact. So when I look up here, I go, okay, 450 is what I started out with. And I started out with, so I'm just copying that down, 450 centimeters. And what I do is I go up to my conversion factors, my ratios, and I look for a ratio, one of these, that is going to allow me to cancel out centimeters, because that's the name of the game, to get the units to cancel out. Well, I look at this one. Nope, that's not going to do it. Centimeters on top. I need something where centimeters on the bottom. Well, it happens to be this one right here. Okay, this is the conversion factor I want to use because centimeters is on the bottom. So I'm going to take that conversion factor and I'm going to write it down right here. And I'm going to put 0.01 meter on top and 1 centimeter on the bottom. Now this entire time I'm not worried about the math. I'm just worried about making these units work so that they'll cancel out. Because right now if I multiply 450 by 0.01, these centimeters are going to cancel, just as 5 over 5 would or 6 over 6 would. A centimeter over centimeter cancels out. Now I look for my second conversion factor, all right? Because right now I'm talking meters. Ultimately I want to get to nanometers up here, wherever it was, okay? I want to get to nanometers. So I look these conversion factors. Well, this one isn't going to do it because if I draw this conversion factor down there and multiply that, I'll get meters squared. I don't want meters squared, I want nanometers. So I look over here and go, okay, this is the one I want. So I'm going to write it right down here. I'm going to put 1 nanometer on the top, 10 to the minus 9th meter on the bottom. Again, I know I have done it correctly because the units meter cancel out. The last remaining unit are nanometers. That's what I want in the problem. So I am guaranteed that I have done this, set this problem up correctly. All I need to do now is to pick up my calculator, plug in 450, multiply it by 0.01, multiply it again by 1, divide it by 1, then divide it by 10 to the negative 9th. What I get out of that is 4.5 times 10 to the 9th nanometer. And I am guaranteed that I did that problem correctly because the units canceled out. The way I set it up, it's got to work. Nanometers here, the only unit that's remaining that hasn't been canceled is nanometers. I did it correctly. I have 2 sig figs in my answer. Okay, that's correct because I had 2 sig figs in the value that went into the problem. Sig figs for equalities are considered to be infinite, so you'll always base the proper sig figs off of the number that's given, not the equality. So that's dimensional analysis.